Welcome to the course module Introduction to Similar Exposure Groups. My name is Rachel Jones, and I'm a professor at the University of California, Los Angeles, Fielding School of Public Health. The learning objectives for this module are: first, explain the concept of a similar exposure group. Second, explain the role of variability in similar exposure groups. Third, define and develop an exposure profile. And fourth, explain the role of similar exposure groups in exposure measurement strategies. In this part of the module, titled Concepts and Definitions, objectives 1, 2, and 3 will be addressed. A similar exposure group, or SEG, is defined as a group of workers having the same general exposure profile for an agent or agents, because of the similarity and frequency of the tasks they perform, the similarity of the materials and processes with which they work, and the similarity of the way they perform the task. Basically, all workers in a similar exposure group have similar exposures. The definition of a similar exposure group used the term exposure profile. An exposure profile is a statistical description of the magnitude and variability of exposure experienced by the group of workers in the SEG. We know that the exposure to an agent during a work task or job can vary somewhat from day to day or between workers. This is a normal, natural process. It means that the exposure will not be the same every time the task is performed. The term exposure profile reflects this variability in the magnitude of exposures. Why do we need the concept of a similar exposure group? Well, the industrial hygienist's goal is to understand occupational and exposures for all workers to all occupational hazards on all days of work. In a workplace, however, it's generally not feasible to measure the exposure of every worker on every day. Instead, the industrial hygienist measures the exposures of selected workers on selected days and uses these data to infer the likely exposure encountered by other workers performing the same tasks on other days. The group of workers for whom the measured exposures are relevant comprise a similar exposure group. Basically, the hygienist measures the exposures of some workers, and with enough data, can be justified to consider the data are statistically representative of all exposures experienced by workers who perform the same job tasks. Misclassification is an event that workers are incorrectly classified into an SEG, or similar exposure group. That is, some workers are assigned to an SEG, but their exposures cannot be represented by the exposure profile of the SEG. There are several reasons that misclassification can occur. First, job titles may be very broad. When this occurs, workers with the same job title may work in different process areas or perform work tasks that lead to different exposure profiles. For example, many workers in oil refineries have the job title of operator, but they work on different process units where they encounter different hazards and have different exposure profiles. In this case, assigning workers to an SEG just based on their job titles is going to lead to misclassification of exposures. Second, work tasks may not be evenly divided amongst the workers in an SEG. It is not uncommon that workers with the same job title perform different tasks. This may be because workers specialize in tasks, but it can also arise because of discrimination or segregation in the workplace. For example, studies have found that female cleaners are assigned manual cleaning tasks, while male cleaners are assigned cleaning tasks that use automated equipment. As a result of this specialization, female cleaners have a very different exposure profile with respect to ergonomic risk factors than male cleaners. This specialization, however, resulted from discrimination because women were judged unable to operate the automated equipment. A third reason is that professional judgment may not match the measured exposures. This can occur because the hygienist doesn't have sufficient information about the work tasks organization of work, or exposures to correctly identify which work tasks and workers belong in the same exposure profile. To avoid this cause of misclassification, exposure modeling or monitoring should be used to define or evaluate SEGs. Overall, to minimize misclassification, the hygienist must have a good understanding of the work activities. Such understanding can be gained through observation of the work and conversations with workers. Exposure modeling or exposure monitoring data can also be very helpful. An exposure profile is a statistical description of the magnitude and variability in exposures experienced by a worker or group of workers. Developing an exposure profile requires multiple exposure measurements of workers within the similar exposure group. The profile is modeled based on an assumption of a probability distribution. Generally, exposure data are assumed to follow a log normal distribution. That an exposure profile is a statistical description rather than a single value reflects that there is variability in exposures. There are two primary sources of variability in exposures that can influence the exposure profile. Those are within worker variability and between worker variability. Within worker variability occurs because of differences from day to day. Day to day, the work environment and the way a worker does their job can change. Some potential sources of day-to-day variability in exposure are the pace of work, which may increase. An increased pace of work may increase the frequency of the exposure. The workplace temperature may increase. The temperature may increase because of the ambient weather conditions. Increased temperature may increase evaporation of volatile chemicals, increasing exposure. The local exhaust ventilation hood may be put in a slightly different position. Mobile local exhaust ventilation hoods are put into position by workers, and the worker may position the hood differently from day to day. The position of the hood affects its capture efficiency. As a result, the position may increase or decrease contaminant emissions, affecting the exposure. Between worker variability occurs because each worker may do the work task somewhat differently from one another. For example, from one worker to another, the worker's head may be closer to the source because of their height. The pace of work may be slightly higher or lower. Workers with years of experience may work more efficiently than those of less experience, or workers are simply doing different tasks at work. All of these elements can lead to different exposure levels for different workers. Previously, I mentioned a study of ergonomics among cleaners that found that female workers were assigned tasks that involved manual cleaning, whereas male workers were assigned tasks that involved motorized cleaning equipment, leading to meaningful differences in exposures to awkward postures and repetitive motions. This situation is depicted in the figure. There are two job tasks denoted in red horizontal boxes. Job task 1 is manual cleaning and job task 2 is motorized cleaning. The workers with the job title cleaners include 4 women and 3 men. The women all perform job task 1 and the men all perform job task 2. 3 vertical boxes denote the women and men working on days 1, 2, and 3 doing their job tasks. Variability in the exposure profile can appear as between workers in 2 ways. There is variability between the 2 job tasks because the manual and motorized cleaning involve different activities. There is variability between workers doing the same job. For example, the exposures may vary among the 3 men on one day performing the motorized cleaning. Similarly, there is variability in exposures among the 4 women on one day performing manual cleaning. Variability within workers occurs across days. For example, the man in the blue outline may have different exposures on day 1, day 2, and day 3. In this example, the male and female workers should perhaps be considered to belong to different SEGs because they consistently do different tasks. One SEG could be defined for manual cleaning and another SEG defined for motorized cleaning. Qualitative or quantitative data about the exposures of the workers can help the hygienist to make that decision. Here we see the same group of cleaners, but both men and women perform manual cleaning and motorized cleaning, and the men and women assigned to each job varies from day to day. There are still differences in exposures between workers performing the different job tasks and between workers performing the same job tasks. And there's variability in the exposures within workers owing to what they do each day. In this example, however, because workers perform both manual cleaning and motorized cleaning, it may be appropriate to represent the exposure profile of cleaners by a single SEG rather than two SEGs. A well-defined SEG should include workers that can be represented by the same exposure profile. There may be both within worker and between worker variability present, but the between worker variability should be limited and should not reflect systematic differences, such as may arise from specialization of job tasks. If variability in the exposure profile is high, the industrial hygienist should ask, should these workers be in the same SEG? In other modules, we discuss how you can determine whether the variability is high.
This lesson has been created by the Interdisciplinary Training, Education, and Research Activities for Assessing and Controlling Contaminants from Emerging Technologies program, a collaboration of the University of Minnesota School of Public Health, the University of Iowa College of Public Health, and the University of California, Los Angeles Fielding School of Public Health. Funding for InTERACCT is provided by the National Institute of Environmental Health Sciences of the National Institutes of Health. The content of this lesson is the sole responsibility of the developers and does not necessarily represent the official views of the National Institutes of Health.